All right, so welcome everyone to our August 2023 Clinician Engineer and Qatar AI in Medicine Journal Club session. This is the first time we sort of merge efforts between both entities. So this is going to be a Clinician Engineer Hub webinar and an AI in Medicine Journal Club session. So joining us today from the Mayo Clinic AI Lab in Minnesota in the US is Dr. Shahriar Faghani. So I hope I pronounced that correctly.
Yes, thank you.
Okay, great. So his expertise and his insights are for sure going to enrich our understanding of the dynamic intersection between AI and medicine. He is going to be talking about NVIDIA MONAI, and that will be followed by a thought-provoking panel discussion featuring prominent figures in the industry. We have Dr. Seyed with us today from NVIDIA in Munich, Germany. So Dr. Shahriar, I'll give you the opportunity to talk a little bit about your work before we sort of start sharing slides. So if there's anything in terms of self-introduction that you'd like to do.
All right, thank you for inviting me.
Thank you.
So I'm gonna share my slides. Right, so can you see my screen?
Yes.
Okay, great,
Yeah.
perfect.
Great, perfect.
All right, so I guess today I'm gonna briefly discuss about some of the real-world applications of AI in medical imaging using MONAI. And so in this talk, as all of you know, we have different terms, AI, machine learning, and deep learning, but my focus is going to be on deep learning. And there are many categories of input data that we can work on, but like tabular data, textual data, sequences, which are going to be processed in NLP domain. But again, my focus today is computer vision. So to have some sort of classification or categorization in mind. So basically, different tasks in computer vision domain from computer science perspective can be categorized into classification, regression, object detection, segmentation, and generation, which you have probably heard about it a lot in recent month about generative AI. And from medical perspective, these tasks could be categorized in diagnosis, prognosis, treatment response, detection, generation, etc. So I'm going to talk about some of these applications from both perspectives that we have developed, and we used MONAI for developing these applications. So before getting started, if you are interested more in knowing more about the applications, types, designs, and challenges, feel free to read these review paper that we have published a few months back. But so I'm going to start with this one. So, GBM or glioblastoma is the most common primary brain tumor, and they're really malignant. And the way that we treat them is maximal surgery followed by chemoradiation, right? But after chemoradiations, 1/3 of patients will show signs of regression in their imaging, which is fine, right? We love it. But the other 2/3 may show some sort of progression signs, but half of them are really true progression, which means recurrence of the tumor. And for the other half, these progression signs might happen due to inflammatory changes. And even expert neuroradiologists cannot differentiate between these two entities. So that's why we try to develop a classifier, a classification domain for treatment response, medical domain, an AI model in general, to differentiate between these two important categories, which is a really important clinical problem. So we use MONAI, basically MONAI Core, to develop these pipeline. And we publish the results in Journal of Neuro-Oncology. So again, if you're interested, feel free to read more about it there. So the other application, so we can use segmentation and detection for prognosis purposes. So what I'm talking about is, multiple myeloma is the second most common hematologic malignancy. And it's going to be presented with some lytic lesions within the bone, right? And we have an imaging which is called a skeletal survey. So it is a CT scan basically from the head vertex to the mid thigh. So basically, it's going to be a huge CT image, right? About 1,500 slices. And these lytic lesions are really tiny lesions, like the one that you can see a red bounding box around it. So basically, for determining the prognosis of multiple myeloma, one way is to quantify the burden of these lytic lesions. And it is really a tedious task for musculoskeletal radiologists to go through all of these slices and found the lytic lesions. So again, we used MONAI to first segment the bone like this one, as you can see. And then we multiplied these segmentation masks to the original image to just get rid of the rest of the image because we are only interested in the bone. And then we trained a detection model to find these lytic lesions. So basically, we automate this whole process, which is going to take just a second to scan and get the burden of the whole skeletal survey. The other thing is we're doing also radiogenomics. So basically, we can predict genetic markers from imaging. Again, there are many ways to do it, and there are many diseases that we can predict the genetic markers from the imaging. Like the one is here for predictions of MGMT, which is a genetic marker which is important in tumor response in glioblastoma. So again, we used MONAI to develop these whole pipeline. Again, we can use imaging to do some regression tasks. Again, we can use images to exactly predict the overall survival of a patient. So basically, it's a regression task. So in this work, we use again MONAI core to predict the overall survival of glioblastoma patients. The other work, we used here MONAI to develop a generative model that we can in-paint brain tumors. What do I mean by that? So probably you've seen a lot of AI mobile app that you can change some attributes of the image. So you can, for example, if you have a photo of a face, you can make smile in it. You can change the eye color, right? These are generative tasks. These are generative AI-based tasks. And basically here we did the same thing. So in this work, we developed a model that you can, for example, erase a brain tumor from a brain image, or vice versa, you can introduce a tumor in the brain image. And it's going to do it intelligently. What do I mean by intelligently? So basically, when you introduce a tumor in a brain image, it's not just a tumor, it's not just a mass. It's going to have some surrounding edema. It's going to make some changes in the adjacent pixels, which we call that midline shift. It's going to affect the other areas. So these AI model that we've developed will take care of all of that. So again, for the entire pipeline, we used MONAI, and recently MONAI has added a generative tutorial, a lot of generative tutorials. So basically, you can play with them, and it makes a lot easier for you to develop these kind of pipeline. The other one, so we use images, basically heap images, to predict the risk of dislocation of total heap arthroplasty. Again, for the entire pipeline, we use MONAI. And at the end, I will tell you why I'm insisting that we use MONAI. What are the advantages of using MONAI? The other one. So in this work, we've developed some generative AI models that we can prompt our model. So for example, I want a hip X-ray for a female with BMI of more than 25, and I want this patient be more than 65 years old. And then basically this model will create an matching hip X-ray for me based on my prompts. So again, for the entire pipeline, we use MONAI. There are some other works. Again, we can use deep learning based model to generate some missing sequences, like we can generate T2 images from T1 images. We can generate FLAIR images from T2 images, and etc. So basically, now there are some tutorials in MONAI that have gone through some of these examples, so you can use them. Also, it's not just radiology. You can use digital pathology slides to get a lot of information out of them. And the good news is that MONAI is also integrated pathology workflow into it. So now you can use MONAI easily to process and develop AI models for digital pathology. In this work, we developed a model which we call the Bedlam, that it can scan the entire whole slide image, these images are really huge images, like 40 gigabytes, 50 gigabytes per image. And then it can scan all these slides, find some dysplastic regions, and then afterward it can scan the exact region and assign the exact grade of dysplasia to that specific region, and then to the whole slide level. And so we've also provided a lot of tutorials and notebooks, and we use MONAI in all of those notebooks. So again, if you're interested in developing these kinds of applications, feel free to visit our website, which is called meedle.org. And so we have presented some workshops last year or this year at NVIDIA GTC. One was exploring uncertainty quantification in deep learning for medical imaging. The other one was deep dive to image generation for medical imaging. And you can access them if you log into NVIDIA GTC platform. We use MONAI for doing UQ and image generation. So again, if you're interested, feel free to check out them, and stay tuned for GTC 2024, which we're going to have a lot of interesting topics next year. So this was my short intro, and then I'll happy to take any questions, and looking forward for our discussion panel. Thank you.
Thank you very much, Dr. Shahriar. So we actually have a lot more time than I expected. So I suppose we can take down a few questions before we officially begin the panel discussion. So questions in the chat, or if you would like, you can also unmute and address your questions directly. I can see that we have Dr. Susadolaya. She's back in, so she is our faculty lead. And we also have Paolo. Hi, Mr. Paolo, from simulation at the University of Cambridge.
Hello, everyone.
Okay.
Sorry, I'm a bit late. I was stuck in traffic.
It's all right. Thank you for joining us. Okay. So let's see. Questions. Let me see the chat.
So
we don't seem to.
Maybe I can elaborate more on why MONAI is useful.
Oh, we have one actually. Dr. Sumaya has a question.
Thank you, Dr. Shahriar, for the interesting talk. Actually, I'm also interested in computer vision and image processing, and some of my applications or research related to medical image processing. I log into the website you mentioned. Do you have can you share with us some data sets?
So, if you mean a public data set, in this website,
Mm.
yeah, in this website, we've just used publicly available data sets,
Mm-hmm.
and they're mainly from Kaggle and some
Okay.
publicly available competitions like RSNA competitions or SIM competitions. But for metadata, no, we're not allowed to share metadata. But I guess there are plenty of publicly available data sets that we've used them in the website that I mentioned.
For the bone density, the one you mentioned, do you have this is a public data set or
For which one?
X-ray data set?
So I can't. So the voice.
I
is-
think
I
she's
think
saying
the
bone
internet.
density, the bone density X-ray data set, something along those lines.
Oh, the HIP data set. No, the HIP data set. The HIP data set is Mayo data set. So no, not here.
Okay, thank you very much.
Of
I
course.
will leave that.
Yeah,
Thank
if
you.
you're interested in more collaboration, yeah, probably we can sign some IRBs and some institutional contract. But yeah,
Yeah, sure.
they're not publicly available at least.
Okay. Thank you. Thank you very
course.
much.
Okay, great. I suppose I can connect you to via email later on once we're done with the journal club. All right, we have two questions in the chat. I suppose we could take one. The first one is from Irene. Irene is asking if we could transform X-ray into MRI using AI.
Well, great question. And it's an active area of research, and we're currently working on this similar thing, not X-ray to MR, but X-ray to CT, which is more relevant, right? Because in the X-ray, you lose a lot of soft tissue information, which is going to be highlighted in MRI, but you'll have a lot of information. I don't know why the voice is like that.
We can still hear you. We can hear you.
Okay. Great. So yeah, but you can still catch a lot of bony structure information within X-rays. So and there are a lot of research on converting 2D images to 3D images. And basically, there are a lot of works in computer graphics. So, and there are many models which is called NERF, NERF, neural rating. So yeah, there are some ways that you can convert X-rays to CT, but still they're not well developed. And at least as far as I know, there are many teams that are working on these huge and important problems. Yeah, great question.
Great. Irene, I hope that answers your question. We have one more. It is 7:20. I suppose we could take it. Selma is asking, do you think this is a useful tool, maybe for people who need to wait a long time to visit a specialist to get an understanding on their X-ray or CT, or is this specific for medical professions only?
Again, great question. So I think these applications would be for medical professions because still these are just predictions, and you cannot trust them, right, as a gold standard. There are a lot of legal issues around them. So who's responsible for wrong predictions? Who's responsible for correct predictions? So still, we do need the confirmation of physicians afterward. So these works are basically are used for kind of assisted tools for physicians, not replacement for physicians. So yeah, again, then my short answer is no, they're just assisted tools for physicians.
All right, okay, so thank you very much. I don't suppose we have any more questions in the chat, so we can head right into our panel discussion. So as Dr. Faghani wraps up his talks, just get ready for something just as exciting. We have our panel discussion. We've got Dr. Seyed-Ahmad Ahmadi, the deep learning guru from NVIDIA, EMEA region, and he's in Munich. And we also have Dr. Sousa Zalay with us, the AI and medicine faculty lead from Qatar University. Hi, doctors, can you hear us? Everyone all clear? See everyone? Okay, great. All right, so we want your questions, we want your insights and your curiosity to fuel this chat. So although we sort of have an idea as to where this panel discussion will go, you are most welcome, all attendees are most welcome to address their questions or anything that basically spurs up in the moment. So again, this event is a mashup for the Clinician Engineers Hub webinar, as well as the Qatar AI and Medicine Trial Club. All right, okay, so let's get started. Beforehand, Dr. Seyed, would you like to just give a brief introduction as to what you do and what is done at NVIDIA with regards to MONAI?
Yeah, again, thank you for the introduction. Happy to briefly introduce myself. My name is Ahmad. I'm a senior solution architect for deep learning in healthcare with NVIDIA in the EMEA region, Europe, Middle East, and Africa. I joined NVIDIA roughly 2 years ago. Before that, I did my PhD at Technical University in Munich. Also, back then it wasn't deep learning yet. It was still called machine learning, and deep learning didn't exist yet, at least not in the wider community. I worked from the very beginning, though, with machine learning models and machine learning algorithms on medical data in the operating room for medical diagnostics. Dr. Shahriar, he gave a nice overview in the beginning. And then I did my postdoc at neurology here in Munich, and I became group leader for medical AI at the German Center for Vertigo and Balance Disorders. And then I joined NVIDIA. And throughout this academic life before NVIDIA, I worked a lot with medical image analysis. We developed a contribution that some people may know. It's called VNet and the dice laws for segmentation. It's pretty popular, part of MONAI also. I'm very happy about that, that it's found wider adoption in the community. And shortly, like let's say 1.5, 2 years before I joined NVIDIA, I discovered MONAI. I started working with it in version 0.1, like in the very early days. And I really enjoyed it, and it boosted our lab, even though we had quite some experience with deep learning. And that was in version 0.1 and 2, and now we're at version 1.3. I think the functionalities are exploding, and it's just such a fantastic tool. NVIDIA, your second part of the question, Yusra, NVIDIA, how is NVIDIA related to MONAI? NVIDIA is one of the founding members of MONAI, Project MONAI. The idea of it was conceived around 2018-19 by NVIDIA and King's College London. NVIDIA had its own framework. It was proprietary, closed source, called NVIDIA Clara Imaging Platform. And King's College had its framework called NiftyNet, and a very popular TensorFlow-based framework. And the idea was that all of these tools, they are very functional, but all of them have reinvented the wheel to a large degree. And it would be great to join forces and let the community work on this together to create one framework that really boosts the whole community as a whole. That idea was pitched to the MICAI Society and fell on really fruitful grounds. An advisory board was formed. Stephen Aylward is heading that until today. And today it's a very community-driven framework. NVIDIA and King's College still contribute a lot. Shahriar Dr. Shahriar mentioned the generative AI package that was recently added in spring. That was another fantastic, really outstanding contribution by King's College. And NVIDIA engineers, our colleagues here, they work on research, they develop their models, they try things, but mainly our task is to make sure that this framework is very performant on GPUs, obviously, even though it's not restricted to GPUs only. We make sure that it has a lot of functionality. It meets client demands that we hear from the field solution architects like me and Rashid, who is also on the call. We talk to a lot of clients. We hear about their needs, and we kind of condense that into recommendations for how the framework should progress. And there's also a lot of a very important aspect. MONAI has really high quality code, at least in MONAI core. There are fields where researchers can contribute regular research code, let's say, but MONAI core has a bit of a quality standard to it. There are unit tests, code style checks, continuous integration platform, and these things. And this is also managed by NVIDIA. And but really, it's a big community framework. We have dozens of academic medical centers who contribute to it, who use it. Very happy to see the slides and the presentation of Dr. Shahriar today. It's absolutely exciting to see what academia is doing with it. And we have really large footprint industrial clients who use MONAI, who have fully productionized it for internal research use. The R&D departments like it a lot because they get access to state-of-the-art models and approaches and training recipes and tutorials, a lot of it for free as open source. And it's just grown to this beautiful framework that the community is contributing to and using. And yeah, quite exciting.
All right, amazing. Well, I'm very excited to hear more about it as we progress along the panel. But before we officially get started with the panel discussion, I want to give Dr. Faghani the chance to also introduce himself beforehand. We didn't really get to do that much at the beginning of the webinar. Dr. Faghani, can you hear us?
Yes. So, yeah, again, I guess you introduced me, but I'm also coming from medical background, so I'm a medical doctor, but with a background also in mathematics. Then after my med school, I guess, yeah, I joined the Mayo AI lab about 2 to 3 years ago at Mayo Rochester. And since then, I'm working on developing AI model that I introduced some of them to you. And in addition, I'm working on some theoretical aspects of deep learning, which again, I introduced one of them, which is called uncertainty quantification to build trustworthy AI. So still, I'm heavily work on that to integrate uncertainty quantification into medical imaging and also large language models, which has been recently introduced. So from the beginning, I started, when I started medical imaging and deep learning, I started with MONAI because, and the reason is, so in those days, there was just MONAI. And now we have 3 branches of MONAI, which is MONAI Label, MONAI Core, and MONAI Deploy. So, and the reason that I started with MONAI was MONAI is really makes it easy for medical imaging. And I guess there are 2 main reasons for that. One is when you develop an algorithm, you need to create some data set, right? And when I say data set, it's not just a bunch of data. So when I'm talking about data sets in deep learning, you need to pack them, you need to organize them, you need to connect them very meaningful and very efficiently. And MONAI data sets makes it really easy, as opposed to PyTorch, vanilla PyTorch. The other thing is that MONAI has a lot of medical imaging specific transformations, which to me is the main strengths of MONAI, one of the main strengths of MONAI core. So basically, for, you know, medical data are scarce. So you need to increase them, right? In deep learning literature, we call these data augmentation. So we need to oversample our images, but we don't want to just replicate them, duplicate them. We want to, when we're oversampling them, we want to create a variation of them, and we want these variations be real looking and what we see in real practice. For example, when we want to manipulate an MRI, we want to see, for example, random noise gaps, which is MRI specific kind of noise, which we don't have it in other domains, right? So you can easily integrate random gaps noise into your MRI images using MONAI, and you can't do it with any other framework unless you hard coded yourself. So this is the other I guess advantage of MONAI. And as Dr. Ahmadi mentioned, the other one is there are a lot of built-in model architectures that you can just grab them and you can just change the number of channels, number of dimensions, anything you wanted, and then you'll have the model. So you don't need to write the model from scratch. So you can just grab the model. You can easily create the data set, as I told you. So we have the data set here, we have the easy transformations here, we can grab the model, okay, boom, you have the pipeline. That's it. So yeah, exactly, that's it. And you can see this in the MONAI tutorials. So why not using this? and now you can also use MONAI label, which you can use it for the annotating of your data sets, specifically for segmentation tests, because it has an active learning component. So after you segment some of your initial images, then the platform itself will learn how to some sort of pre-segment the next samples for your convenience. So this is the other part of MONAI, which is called MONAI label. And at the end, so you have your data set label, you have your pipeline, but this is still feel loose, right? So you can't put these into production. You can't put these into real practice. So you need to package them. You need to put them in a container, in a Docker-like container. And that's where MONAI deploy comes in. So MONAI deploy basically package all of this in a container. Then you can deploy it into your existing workflow, and even you can create a workflow within MONAI deploy, which I'm a part of that community as well. So this is the entire story of MONAI from the beginning. You can label your data set, you can develop your pipeline, and then you can package it for the production.
All right, great. Well, that was certainly a journey. So you go all the way from MONAI label until basically the packaging stage, and then all the way into deployment. Now, I think a burning question for many clinicians in the webinar today, as well as well, faculty or professors from an electrical engineering background or other backgrounds, is what advice do you have for researchers and practitioners that are looking to integrate MONAI into their medical imaging workflows? So what is the learning process like, and how would you describe it? I suppose this question is to both Dr. Shahriar and Dr. Seyed. I suppose Dr. Shahriar, we could start with you, and then we could move to Dr. Seyed and, sort of take it to the flow.
Okay, so I'll see your question like, so I want to move from place A to place B. What is your suggestion of using a car? So then my suggestion is, okay, definitely use it because you want to go from place A to place B. So, but Monai is just a tool, right? A lot of works is behind the development. So is data collecting, data pre-processing, making sure that your data hits a certain quality checkpoint. So these are the main works. And of course, the development itself is a big work, big part, but still a lot of works are behind the scene, right? Is the data collection process. But you know, again, I guess it depends on the use cases that people wants to get out of it. Again, to me, is there are of course certain advantages of using Monai. One is you can integrate it into other PyTorch ecosystem, which is really nice because it is PyTorch based. So this is one. Two, it has a lot of medical imaging specific transformations. It makes creating dataset really easy. It has a lot of built-in architectures. So again, I guess everyone during developing a pipeline will need all of this. And to my knowledge, Monai is the best for these four at least. So this is why I'm using Monai. So I use Monai for these four purposes. And when I need something extra that still is not in the Monai, I can easily integrate it to it because it is not like a black box. You can use each of them separately, and there is no need to use all of the Monai thing in your pipeline. You can grab something from PyTorch, you can grab something from scikit-learn, anything. So you can use them in separate or together. So yeah.
All right, Dr. Seyed?
Yeah, sure. Maybe to reiterate your question, if I understand correctly, your question is how do you take or bring AI that you develop with Monai to the patient? Was that the question?
Essentially, it's more of the development process, but it would be great if you could elaborate on bringing it to the patient as well.
Okay. Yeah, the development process, I think it's really developer specific. I think Dr. Faghani, he explained the most common approach. You need to prepare your data, you need to choose your model, you need to choose your transforms, augmentations, like train and validate your model. All that is Monai core. Data annotation also can be supported with AI assisted annotation in Monai label. That was also already mentioned. There are newer aspects to the platform that can, depending on how deeply involved the data scientists working with Monai are already with such advanced concepts. For example, experiment management. You can use platforms like MLflow to track your experiments, to auto tag your experiments. Have some people know TensorBoard, where you can observe your metrics and your losses during training, during validation. MLflow does a little bit more than that. It really tags your experiment almost like Git does for your code. It versions your experiments. If you change a tiny bit of your data, a very minute parameter of your model, it tracks that and makes your entire experimentation history very transparent, repeatable, and you can analyze it very well. I think there are many more aspects on that, but I think the second part of that question is also really interesting, like how, once you've trained your model, what do you do with it? Yeah? And there's this component in Monai that's Monai deploy. And to those in the call who don't know it, it is basically a part of the Monai SDK and of the platform, which has, I would say, 3 or 4 main components. First of all, there's a concept that's called Monai application package. It's sort of an application that is that can be deployed to the clinic, and it contains a workflow, and that workflow typically contains an AI step AI inference with an AI model, a machine learning model. But it doesn't have to. It can also be something else. Typically, though, the AI inference is not the only thing. And this is where the whole MLOps aspect comes in, which makes deployment into clinic so complex. It's not enough to run inference. You need a lot of other stuff. You may need to convert your DICOM to an IFTI first, which then your model ingests. Maybe your brain scan needs to be pre-aligned to one of the common neuroscientific atlases like MNI Atlas, or you want to pre-register your data. You want to normalize it from bias field artifacts, things like that. And these more complex parts of a workflow can be combined with a component called Workflow Manager. And those can then be combined into this MONAI application package. And if you have a MONAI model, and especially something called a MONAI bundle, which is sort of a standardized way to design your model in MONAI, then you have a tool that's called Deploy App SDK that bundles your application into a containerized app and makes it very easy to create these MONAI application packages. And finally, there's one final component that's called Informatics Gateway that helps you to interface with PAC systems, with the DICOM standard, with HL7 databases, FHIR databases, which have multimodal data. And altogether, this allows you to integrate with the clinic. But that being said, Dr. Faghani mentioned it, it's a platform, it's a tool, MONAI. It's not like you can double click installer icon and it installs AI into your clinic. It's not as simple as that. It's still a bunch of components that are really powerful Lego blocks in your tool container. But it does require some effort. Every hospital is so different. Every hospital has its peculiarities. There are standards like DICOM HL7, but even those are very interpretable, let's say, and adaptable and customizable to different clinics, to different vendors and machines. That makes the entire hospital ecosystem an extremely complex environment to work in. And MONAI provides a lot of shortcuts and a lot of cool tools that make this journey much easier, but it does need customization. And maybe a question to Dr. Faghani. You mentioned that you use Deploy, MONAI Deploy, if I understood correctly. You're even on the board, it seems, in the working group. How was that journey for you? Have you brought some of these algorithms from the papers you showed into deployment? And how was that journey?
Yeah, thank you. So yeah, I'm on the working group, but you know, since Mayo it has its own policies, at least in Mayo Rochester, we are not still integrated MONAI deploy to any part of our workflow. But as far as I know, there are some works integrated into Mayo, Florida. Yes, because some of the also core people for the MONAI deploy are from Mayo, Florida, and they have integrated some of these applications into Mayo, Florida, but not Mayo Rochester yet. Yes.
I see. Okay. Yeah, that's another level of complexity. There are also hospitals that develop their own frameworks, and there's also funding attached to it. And it's obvious that the funding bodies would not be happy if you say, okay, well, we applied MONAI deploy and it solved 80% of the problems. We do observe this sometimes. So that's another level of complexity to the whole deployment area. But maybe along that line of that questioning, I mentioned that to Yusra in a prep call before. I'm always fascinated by doctors who code as well as apparently you do, who know how to set up their own data science experiments and publish the papers from a technical perspective also. I wanted to ask you how you have a math background, obviously, but how was that journey for you? How did you discover MONAI, and how difficult was it to get into this ecosystem? How was the learning curve? And just a little bit of that journey for you, especially as a doctor.
Sure. So yeah, my journey was kind of funny. So I guess you are working in neuro, right? And the most interesting, I guess, part of probably medicine to me. So I was really got interested into neuroscience and specifically cognitive neuroscience about 6 years ago or such. And then in those days, again, was the expanding days for deep learning and machine learning, as you mentioned early in the call. So on those days, I felt, okay, I love math, I love neuroscience, cognitive neuroscience, deep learning, especially when you learn, for example, something basics like convolutional neural network, you'll realize that, oh, this is the way that we also process the visual information in our brain, in our occipital lobe. We do have the specific architectures like convolutions there. We do have the exact processing steps. Wow, what amazing! What are the real similarities when you learn more about, for example, attention mechanism, LSTM, for instance? You may realize that, wow, this is hippocampus. Oh, we do have the same mechanism in our brain when we want to attend to something. And that was the reason that I was introduced into deep learning. So exactly the interaction between deep learning and neuroscience. And then, I wanted to be radiologist. So, and this year I'm going to apply for the radiology residency. So yeah, the intersection of neuroscience, deep learning, radiology was, okay, let's do some experiments within the field of medical imaging and AI. That's I guess the intersection of all of my interests. So that was the way that I got into this whole world. And yeah, when I was looking for some platforms, I guess someone mentioned in one of the posts that there is a website which is called Monai for medical imaging deep learning. And I guess it was really in the first days of it. So that was the way that I found Monai, and then I got involved into the communities and societies, which is really great.
Great. So you also joined in the early days.
Yeah.
So, Dr. Shahriar, you code or you develop machine learning models purely using Monai, or have you used other platforms before?
So again, before using Monai, I was a TensorFlow guy, let's say. But afterward, again, in 2020, there was a lot of debates, like which one is better, TensorFlow or PyTorch. And obviously now I guess we can confidently say PyTorch is used more in academics, and it has a lot of more community around it. So that was that was why I switched from TensorFlow to PyTorch, and exactly in one of the PyTorch links I found Monai. So yeah, basically I had the experience working with TensorFlow, PyTorch itself, pure PyTorch, and then now for developing things, I'm using basically Monai, which to me is not different from PyTorch because it's PyTorch based. But when I need something else, which is not still included in the Monai, I can easily integrate it into it. So yes, now my pipeline is mainly based on Monai with some other components from other frameworks. Yes.
All right, amazing. I suppose through this conversation, the way I understood Monai is It's more of, let's say, I'll give you an example. People used to code out websites from scratch, HTML and whatnot in the past. But now, when you want to create a website, you would just go to Wix.com or Squarespace or so on. So is MONAI that comparatively for AI models, would you say? Or is it not there yet?
So what do you say, Dr. Ahmadi?
That's a very good question. I would say I would rather see MONAI. If you want to create a website, you don't have to learn HTML from scratch anymore. You use a library that has most of the tools for you. Wix
Yeah, drag
is
and
a
drop, basically.
very sophisticated UI on top that provides maximum user experience and streamlined development, very user-friendly. I would say this is what maybe 3D Slicer or OHIF would be to the end user. Yeah, in our case, maybe a radiologist. I would rather say that MONAI is a great platform for developers, at least MONAI Core. MONAI Label gets close to what you were describing. It does not, it is only the AI logic though, as MONAI Label server. It strongly depends on a user interface, which could be something like Wix. Often in our case is OHIF, 3D Slicer. I know that MITK is working on support of MONAI Label. Other viewers, Infusion, and that provides this sort of user experience. But it's really a fantastic tool for data scientists to develop their tools. There are companies and startups that are, or consultancies that use MONAI to bring it to that level that you're describing, customized and tailored to the particular client that they're, for example, consulting. A big company there is Flywheel, which uses MONAI to bring it to build deployment engines, or Newton's Tree, which uses MONAI Deploy they developed a platform called AID, which basically uses MONAI Deploy in the backend to serve the 10 largest UK national health system trusts, which serves, I think, 25 million patients per year. So these are partners that it's very similar to the NVIDIA model. We, as NVIDIA, we develop platforms that enable applications that were previously maybe difficult to achieve or not very performant. And then NVIDIA develops a new platform, and then it depends on partners to flesh this out so that the end users can use it. This applies both to the hardware and software aspects that NVIDIA creates. And MONAI has a similar approach. It created all these fantastic AI logic tools in MONAI Core, a fast API for web communication to your AI server in MONAI Label. It depends on user interfaces though. And it has MONAI Deploy, which has a lot of tools for deployment. And now it relies on partners, can be academic partners, can be industrial partners, startups, consultancies, that bring this and flesh this out and customize it to this really difficult environments in the clinic, let's say.
Yeah, I want to echo what Seyed-Ahmad said. So, still for the development part, you need the understanding even of the basic concepts, or it's better to say you need the understanding of all concepts, but you don't need to create them from the beginning. So you need to understand how a VNet works, how UNet works, because you don't want to just use it, right? Sometimes you need to tweak it. Sometimes you need to alternate it. So you need to have the understanding what are these parameters are, right? But because there are already built in, so if you want to tweak a little part of a unit, you don't need to create it from scratch. So you can just grab it and just tweak that little part, right? But still, you need to understand what is dropout, why you need to use dropout, how it works, right? what is batch norm? Should I remove it here or not? So based on the result that I logged through MLflow, WMB, TensorBoard, whatever. So when I'm tracking my, for example, results, I see a certain pattern which I don't like it, so I want to change it. What should I do now? Because all I have is a unit, right? So still I want to tweak it, I want to change it. So that's where you need the understandings of deep learning. So again, using MONAI is not equal to I don't need the understanding of deep learning. I can do AI without any understanding. No, it's not correct. But it makes it a lot easier if you know the concepts. So I guess this is the way I'm thinking of MONAI.
Okay, well, great answers. And I suppose that clears up a lot of the different ways, so you hear a lot about MONAI, but it's not really clear if it's, like I said, more of a Wix.com, but for AI, or if it's more of a, hey, here is a nicer version of PyTorch, or a more medically oriented, more medical application kind of version of PyTorch. I'm very happy to hear that, actually, because I have been struggling a little bit with PyTorch as to some things that you specifically do when you're building a medical or a medically oriented AI algorithm. But I also ask because at the AI in Medicine elective, we're essentially teaching students during our hands-on sessions, so medical students, sometimes master's degree students, lots of different backgrounds. We're trying to teach them what different components of the pipeline do. And so we get them to run ready-made components that they sort of drag and drop in. But we did this using Google Colab notebooks sometimes, Jupyter notebooks and so on. But I can see how MONAI would fit in nicely into that flow because you still require that basic understanding of what each component does and why you would use it before essentially implementing it, which is also great for, time-consuming algorithms. Sometimes it takes months and, you have to consult with all sorts of different directions before you move on to the next step. So that's nice. But can you share, and this is to Dr. Seyed now, can you share or discuss other roles or maybe other NVIDIA solutions, or maybe even just MONAI, in facilitating, integrating deep learning in healthcare applications? So we've touched on it a little bit, but I'm wondering if specifically there are other ways that MONAI has been used, or perhaps other applications that have been used within healthcare that NVIDIA was a part of.
Yeah, MONAI is really, it was conceived as the primary tool for medical imaging. That was the first use case. But note that MONAI, that stands for Medical Open Network for AI, it does not have imaging in its title. This project MONAI is really was always intended to become a platform for best practices and state-of-the-art tools in medical data analysis. And in that sense, it goes beyond imaging. Nowadays, you can combine language models with MONAI. You can to embed medical text from, let's say, a radiology report. You can use MONAI. You can integrate genomics data from genomics analysis and genomic embeddings or genetic marker that were identified externally into MONAI. You can really use MONAI to build multimodal models. And this is also the research area where I was working on before I joined NVIDIA. And it's also one of my strongest interests still. And MONAI can be used for that. And I think even Dr. Faghani mentioned multimodal tools. But this really ties into the other aspect of this question about which other healthcare applications NVIDIA addresses. And it's really fascinating to me because I joined 2 years ago and it's been a while, but it took me sort of almost a year to fully understand the scope of what is happening here at NVIDIA, and let's say broader in the healthcare domain, and how AI is revolutionizing this field. And maybe the way that I like to explain it the most, also because it helps me to digest this whole scope of it, is that AI is really revolutionizing all of healthcare on all scales of spatial size. Let's say you can look at molecules, and AI models help us to design molecules specifically for drug targeting, for new drug design, and it helps us to understand the genetic code, genomics. NVIDIA has a toolkit there called Parabricks. And for drug discovery, we have Clara Discovery, the platform, and Clara Discovery Service on our cloud instances, DGX Cloud. And this helps you to, let's say, understand disease like COVID, for example, analyze its genome, understand the spatial 3D structure of the pathogen. You want to design a particular antigen that you want to develop a vaccine, for example. You can design the appropriate amino acid sequence. You can predict how it folds into a 3D structure, for example, with algorithms like AlphaFold 2. And these tools are in Clara Discovery and in our platforms. So from that, you go from the microscopic world to more macroscopic world of organs. For this, we have MONAI, we have Clara Imaging, and the MONAI platform to do everything that we discussed now about imaging. Once you go higher scale from organs to maybe whole clinical workflows, especially surgical workflows, there's a platform called Holoscan. And Holoscan is for integration of real-time sensors, but in really the NVIDIA way, sort of maximum performance to make things possible that weren't possible before. You can take up to 30 video streams that you record in the OR in full HD, stream them into a tiny box, shoe-sized box, which has a dedicated GPU, process it with multiple concurrent AI models on a single GPU to process your data in the operating room. And that's called Holoscan. And it's a pre-certified hardware and software platform so that medical instruments providers can build intraoperative devices that are extremely fast and performing basically by completely circumventing the CPU, stream data on GPU, and you process everything there. And then from the operating room, you can even go higher. You can go to hospital scale, and you can process hospital scale data science with accelerated libraries like Rapids. There's another open source library from NVIDIA. Then if you go across hospitals, you can use NVIDIA Flare, that's our federated learning platform, to fuse data from multiple hospitals without having to share the data, and train models that are extremely robust and generalize really well because you train it on cohorts from different countries. We have active consortia and teams who are working across China, Europe, US, Africa also, to include minority communities whose data representation are not fully there yet, and to improve their representation in the models. And up to nationwide hospital systems and data science on that scale. So it's really mind-blowing if you realize what is happening from entire healthcare systems down to the molecular level, and everything being accelerated with AI and making things possible that weren't possible before. So it's really exciting. And NVIDIA basically plays on all scales and on all deployment platforms. Can be edge in the operating room, can be workstations under your desk, can be data centers and cloud. And yeah, NVIDIA really is trying to help clients in all these areas, let's say. And MONAI is a particular example because it's a community-led and community steered platform with a co-organized academic industrial advisory board. So it's a particularly cool example, I think.
Yeah, I have to say.
But I'm very biased also.
Well, all right. Okay. So, I mean, I was going to follow up with a question of specific medical imaging examples or even other medical applications, but you covered that as well. And that's fascinating to hear. I actually had the impression that MONAI was mainly a medical imaging only tool, but it's nice to see that it's actually a lot more comprehensive. Now, before I move on to perhaps a more directed flow for this conversation, I want to open up the panel discussion to audience for any questions so far, anything that you would like to discuss that you think we should have discussed. you can use the chat, you can unmute and just, share your thoughts. You can raise your hand beforehand. So there is a raise hand option on WebEx. So that will let me know that you're trying to unmute. Wait a bit. If not, then I suppose we could just continue with the conversation. Okay. Well, I suppose we were either very comprehensive or there are things we're missing out on. So one of two. Okay. All right. So I suppose I wanted to ask what it is, or how do you envision somebody moving from, let's say, using PyTorch on the regular? So for instance, let's take myself as an example. Lots of work on PyTorch, and now I want to move to Monai because I think it is more suitable for what I'm doing or the work that I'm addressing. This goes to both Dr. Seyed and Dr. Shahriar. Suppose either of you could start, but if you'd like, Dr. Shahriar. You're on mute. Okay, I think you have to unmute.
So is that your question? How you can move from PyTorch to Monai? Is that correct?
Yes. So let's say I have existing work on PyTorch and I want to now shift to Monai.
So then all you need is to do pip install Monai and then import Monai. So because the rest is just summarization of the PyTorch, because still you'll have the same structure in PyTorch. So what you does in PyTorch is so first you're going to create a data set, right? Then you're going to create some transformations. Then you're going to create a data set, a data loader. And then you're going to create your model. And then you're going to have a training loop, right? And within the training loop, you're going to log your basically metrics. That's the entire framework, right? That's the entire pipeline. So using Monai allows you to create the data set just much easier, but in the same way, in the same concepts. But for example, there is a thing which is called dictionary-based data set and dictionary-based transformation. So you can assign so in order to create a data set, then you need to create a list of dictionaries. So basically you can have, for example, this is the image, the path of the image, the key is the image, and then the value is the path of the image. Then you will have the label and your value, right? So then this is a dictionary, right? So then you need to have a list of these dictionaries, and all you need is you need to pass this list of dictionaries plus a pre-specified transformations, which again, the structure is pretty similar to PyTorch, but Monai allows you to integrate more medical imaging specific transformations. So all you need is to create a list of dictionaries, add some dictionary-based transformation, and then boom, you'll have your data set. Then then exactly like PyTorch, you need to pass your data set, your batch size, and then it will create your data loader. Essentially, what it does is it tells the computer how to batch data, right? So afterward, you'll have your batches. And then in the vanilla PyTorch, you need to create your model, right? In these, using Monai, you can say Monai dot model dot unit. There we go. You will have your model. And you need to just specify, for example, I'm going to work with CT scan. Okay, CT scan is a 3D image. So the input dimension then would be 3, right? I want to get 5 predictions out of it. Okay, then the number of output channels would be 5. Okay, I'm going to use without CT with contrast and without together. So I'm gonna combine these two into channels. So my input would be a 2 channels 3D image. So I need to specify all of this, and then I'll have the model instead of creating the whole model from the scratch. Then again, you need to have a PyTorch loop, which is you're going to start, okay, for example, I in epochs, blah, blah, blah. Okay, iterate over the data loader and feed the image into the model, get the loss, apply the gradient, and then optimize the model, right? The same thing is going to apply, but the only thing that has been changed was creating data set and transformations and the model. So again, as I mentioned, the pipeline is pretty same to a vanilla PyTorch, but you can make some things, some part of it much easier.
All right, makes sense. Dr. Seyed, do you have anything you'd like to add to that?
Maybe one thing that we haven't talked about yet, apart from being able to say monai.nets.unet, for example, yeah, you can. There's another pretty cool thing that there are foundational models in Monai. You can use, for example, a particular form of a UNet that was pre-trained on total segmentator, this huge data set of whole body up to full body CT with over 100 annotated regions in there. And our research team pre-trained a model and put that out under Apache 2.0 license, so even commercially usable. And so you don't have to train on your, let's say you only have 50 volumes that are annotated. You don't have to train on that from scratch, but you can actually use a strong pre-trained model and load the weights from that. And there are ready-made tutorials. So also to your question, as a PyTorch user, how do you go from PyTorch to Monai? Well, start with the tutorials. Maybe, in fact, I should put that link into the chat. It's such a cool resource for beginners, not only of Monai, but also people who want to learn how to migrate from or upgrade from PyTorch to Monai, but even for people who are not yet that familiar with deep learning. You learn a lot of the fundamentals, everything that Dr. Faghani was just explaining, from data loading, well, organizing your data into a list of dictionaries, to data loading, appropriate transforms and augmentations, setting up your model, highly performant data loaders that have very sophisticated caching mechanisms, to RAM, to GPU VRAM, and all of that. This is already there in the tutorials. There's a whole tutorial on the acceleration GPU. And someone's happy. And then all of that is basically taught to you.
Stuff that I wanted to try. So 1 out of 2 I could do. Like this thing where there's a spine rotation.
I think we have
Rotation thing. It's so hard. It's like so hard. It's also because I think we're kids. Like I feel like our back can break easily. Here.
Mustafa, I would see your icon shining. Maybe you can mute yourself. Ah, yeah, okay. Now muted. Back to the question. I was saying that, first of all, the tutorials help you, and the link is there. Check into it. You see a lot of use cases: classification, segmentation, registration, acceleration, you name it. And just learn from it. It will probably bring you from even less than PyTorch knowledge to clinical data science in relatively short time. But then there is also this aspect of foundational models. You can use pre-trained models. And if there is a modality that you don't have any pre-training data for, total segmentation is an extraordinary data set to pre-train on, but it's rare to have these publicly. Therefore, total segmentator. I will put a link to that model from the model zoo in the chat in a second. But there are also other models, like a self-supervised pre-trained model that was trained on more than 50,000 3D volumes. Those are CT, MRI, MRI T1, T2, different MRI modalities. I think even ultrasound is mixed in here and there. And on all kinds of anatomies also. It's full body CT, it's brain MRI, head and neck CT, it's abdominal MRI, it's prostate MRI, and so on. These are very strong models. I will put the links in the chat in a second. And it also accelerates your progress there. At the end of the day, I think what's the coolest thing about MONAI is that you don't have to reinvent the wheel. A lot of the things that were just 2 years ago were absolutely state of the art. Literally 5 months ago, or 3 months ago, were state of the art and kind of in the social media and so on. Like this segment anything model, a similar model, MONAI Vista, it's called, is for 3D volumes now available in the Model Zoo. You can use it in MONAI Label to run inference based on click interaction. And it just takes your journey, it just accelerates your journey and cuts it short by months potentially. And this also makes the journey from PyTorch to MONAI so much easier and so much more enjoyable, I would say. But let me put those links in the chat while I was talking about it.
All right, sounds great. There was a question in the chat that I couldn't catch earlier, but I suppose we can address it in a little bit. But this all sounds so good with essentially the immigration process to MONAI, but well, like Dr. Faghani said, it's just an install function. So that's good to hear too. I suppose we could kind of take this conversation more so towards the challenges that you've encountered or that you think are commonly encountered by either beginners or even more so more MONAI veterans in applying MONAI to real-world medical settings, and how it is that you've overcome them and how it is that you would sort of advise a beginner to steer alongside them in a way. We could start with either one of you, Dr. Seyed. You're already unmuted, so I suppose we go with you.
Can you repeat the gist of that question? I was just posting that link.
Yeah.
Apologies.
So, all right, it's all right. So I was asking if you could share challenges that you've encountered whilst you apply MONAI to real-world medical settings and how you've overcome them, essentially. It was more so of a question directed more towards the kind of challenges that a beginner would face. So let's say somebody that just started off with using MONAI, now they have their product essentially, and they're trying to apply it to real world settings. And of course, those that use MONAI more frequently.
I think a lot of the problems have been overcome in the last year. So just a year ago, it was a bit difficult to, well, for example, if you have your model, there's a very cool tool that's called Sliding Window Inferrer that takes your model and applies it on small patches. And it, as the name says, it uses a sliding window approach to infer the whole volume and give you the output. But then it's typically in the frame, in the voxel frame that you did during pre-processing. Maybe you cropped your image a little bit, maybe you pre-aligned it to an atlas. But that whole inverting of that transform chain, that was difficult a year ago. But then core developers, that I think that was an academic contribution from KCL, I think they created an invert mechanism for transforms that are applied during pre-processing, so that the inference result is restored into exactly that voxel grid and into the header geometry of the source volume, let it be nifty or DICOM. So that was difficult, but it's sort of solved. Another thing is that thing that was solved more or less with Model Zoo, yeah, that you want to disseminate your model relatively easily and in a reproducible way so that others can use it in the academic community to reproduce your results or to fine tune from it. And this is now in the Model Zoo, that one model that I just posted there helps with that. I personally am sort of, well, another challenge maybe, what happens if you don't have annotations? That is, I don't want to call it solved, that's too much, but there are really strong recipes for self-supervised pre-training and concrete examples, training code, fine-tuning code for this particular model that I will also post here in the chat. that was pre-trained on 50K volumes, MRI and CT. Basically, not all, but a lot of the public data sets that you can find online were comprised into one, and then a pre-training was run on that with a lot of compute. Auto segmentation, like testing, training and testing different models, ensembling them, similar to what NN Unit does. This was a pipeline, it's a very famous pipeline, very popular, a Nature publication also, and justifiably so, from the German Cancer Research Center. Great method, but there was no MONAI native corollary for that, like no tool that can do the same. And now there is one called Auto 3D-Sec. So a lot of things have been solved and are being continuously solved over the months, and it's very exciting to keep track with the latest developments. But maybe to Dr. Faghani also, maybe you know that from your view, that was also a question I had to you, like, where do you still see limitations from a doctor's perspective, as a developer? Where are things, bottlenecks in MONAI, things that bug you or anything? It's also a nice chance for me to hear and relate to the product teams.
Sure. So then my answer would be in two parts. So for a beginner, which I was 3 years ago, I guess one thing is that I really still like it is, in order to understand what's going on, print the shape of input and output on every stage. Otherwise you're gonna lost at the middle. Because when you apply the transformations, when you apply adding channels, you need to switch the channels, you need to make something, some images channel first, which are not, and the PyTorch and MONAI accepts channel first. So you need to understand these things when you're going to apply, I don't know, cropping, sampling. You're going to know your exact input, output. So when you're getting your data out of data set, the shape is different from before. When you're getting your data out of the data loader, the shape of your data will be different, because now there's going to be another dimension, which is the batch dimension to it. When you pass it through the model, then you need to understand what is the shape of your output, what is the shape of input, what is the exactly thing that you're feeding into your loss function. So again, I emphasize more on understanding the things, and probably before applying these data sets, before applying these things into your own data set, my advice is just copy and paste one of the already built-in tutorial into Google Colab and just follow that, play a little bit with it to feel comfortable with the concepts, and then try to apply to your data set. Because these data sets that MONAI already has are much cleaner data sets rather than real world data sets. So first, I guess it's a good habit to play with clean data set and then move to your own data set, which needs a lot of cleaning perhaps. I guess some there are some still rooms for improvement for MONAI, probably in some documentations of the metrics, and some detailed functionalities of some of the metrics, because it works differently from the common metrics, let's say. Like the DICE score in MONAI is a little bit complicated to work with, because there is an aggregate function. You need to specify include background, no, true, false, and really the documentation is not still in its best shape, in my opinion. So I guess there are some room for improvement there. I guess still MONAI can integrate more interpretation piece to it, like different maps that works 3D, 4D with different number of channels. I guess still we can integrate those pieces into the MONAI. And so maybe some still, if you want to be really inclusive, there are some more architectures, more kind of state-of-the-art models that are not still in MONAI, or even some building blocks that are still lacking. So I guess these are the main things that MONAI still can integrate to its platform. And probably more recently with the development of the LLMs, there should be some ways to integrate LLMs and make it more MONAI friendly to integrate into our medical imaging pipeline. But otherwise, I guess in its current form, still MONAI is really, really good for a start, and still is really, really good to work with. That was my thoughts.
Very cool.
Oh, okay. Yeah. All right. So I suppose let's see, what do we have in the chat? Oh, okay, great. All the data sets and all the links for anyone interested. I also want to remind our participants that they can always write down questions in the chat. There is one question that I would like to address before I continue conversation. But Sam is asking, in the beginning stages with the data set, what do you consider as an outlier? Like, there are rare ways some things can present. Do we ignore them in the data set, or do we work with the data set to include more examples? I suppose this has sort of been addressed through the conversation, but maybe either of you have something else to add.
So I guess it really depends on what project are you working on, what is your data set size, how do you define the outlier? Because you can define outlier in many ways. You can define the outlier by some statistics. You can define outlier by some concepts. You can define an outlier from a data set perspective, or you can define an outlier from a model perspective, or again from the human. So, and then you need to wait if you're considering something as outlier. Is it something that you're gonna see it in real practice? Is it something noteworthy to include it, or no, it's a really crap sample that has been introduced into your data set by sudden, you're not going to see it. So again, it needs a lot of consideration. That's why I said in the chat, I said, there's no short answer to it, clear short answer to it. So yeah, this is my perspective.
All right. Hope that answers your question, Selma. Okay. All right, so we are nearing the end of our webinar, but before we conclude, I have one final question to ask. So I'll start by addressing Dr. Faghani. So I'm very curious about your learning journey with AI in medicine. So I know that you mentioned you have a background in mathematics and that you've worked or that you've explored machine learning individually within neuroscience before you sort of just decided to go into radiology. I looked at the work actually, I found it very interesting. I believe it was the one on diagnosing autism and how accurate it is. It was some sort of review, something like that. But I wanted to ask why you chose to pursue a postdoc position at the Mayo AI lab before starting clinical practice. So did you think that perhaps this is something that is good to work on or hone in specifically before you sort of move into clinical practice? Or how did you make that decision in a sense?
So, you know, this is a famous quote from Jeffrey Hinton, and a lot of people make fun with it. He said, I guess, 2017 that there's no need for radiologists to be trained, so because AI will going to replace them. that was one of the main reasons that I thought I should.
So it's more for you
I
cannot
should
replace
know
it.
AI.
I know how AI.
Yeah, I should know AI. I should know deep learning. So one fact is that deep learning and AI is gonna change the way that we practice. It's still, we're not close to the point that it's gonna replace us totally. Maybe someday, but we're not close to it at least. But so it's gonna change the way that we're gonna practice, and I want to be in that wave of changing, not be changed by the wave. So this is why I thought it's cool to pursue this, and especially it is my interest. So why not pursuing this? Why not doing more research? Why not getting my hands wet really within exact deep learning experiences to understand when I talk to people, because there are some clinicians that still they don't have a clear idea of what is deep learning, what is AI. They think of it as a magic. And when you talk to them, for example, for a project, they want you to do a magic because they really don't have the understanding of how it works. So I thought it's it would be great for me to have these kind of experience and knowledge before I get into clinical practice of radiology. Yeah, that was the reason.
Makes sense. So why the Mayo AI Lab specifically? So what is it at Mayo AI Lab, let's say, that you found very different from other places or other locations? Now, I personally don't know if there's other competing labs or other labs that do the same, where they sort of just hone in on clinicians working with an AI or developing models.
Yeah.
But what sort of just hone in on?
Well, when I was looking for different labs and different people, I found my current program director or lab director, Dr. Erickson. And when I reviewed his work, I thought, wow, this is the thing that I really want to do. And he's in a specific, he's a neuroradiologist, and I want to do neuroradiology. So I thought, okay, this is my role model. So I want to do what he does. So that's why I joined his lab. And after on, I found this lab is really, really great. And so now we are like 70, 18 people, mix of MDs and PhDs. And yeah, we're working on a lot of different projects. We collaborate a lot internally and externally to the other institutions. So I think this is a really nice place, and I'm really happy that I joined here. Yeah.
I'm very glad to hear that. Okay, well, I have a very similar question to Dr. Seyed as well. I am curious why you went into AI within healthcare. So NVIDIA works on a lot of things, and there are so many ways you could apply your skill set, so many ways you could apply your PhD. Why healthcare? And also, what would your advice be to the engineering students that we have in the audience? So we have a mix of electrical engineering and computer science students, medical students as well, and faculty from either end. What would your advice be to them, for those of them looking to do something similar in the future? So it's a two-part question.
Yeah, good point. So for me, it was a bit the opposite. Like, not why would I apply AI to healthcare? For me, it was the other way around. I started in my bachelor's already with applying engineering to healthcare. I remember as a kid already, I was fascinated by MRI scans. I had no idea what they do, how they get to be, but I love those images, and that kind of stuck with me. And can't say it was a calling, but among all the engineering topics, the application vertical that had always interested me the most from the very beginning was healthcare. And then I found this great chair here in Munich, this great professor, Nasir Nawab, and great team to get introduced to healthcare engineering and medical imaging. later, I mean, that was just natural. At some point, you do your classical methods, level sets and whatnot, and they just break very quickly. Yeah? You can engineer the heck out of your model and architecture or your approach, your algorithm, but it's all engineering. And very early on, we realized that machine learning really helps. Yeah? Starting with simple early statistical methods like principal component analysis and so on. But then at some point, random forests were the big thing at our group. We all learned about it. Then manifold analysis with Laplacian eigenmaps, and eventually Tisney came up. And then at some point, I remember that we had the biggest random forests were great, but you need to have features to work on. And that was then the difficulty, like how the heck do we model ultrasound images, which were really difficult, of the deep brain areas, transcranial ultrasound. And we had no idea how to model that. And we were breaking our head. And then one postdoc told us, hey, have you heard about autoencoders? And at that time, that was 2013. It was just like neural network models and like two-layer multilinear perceptrons. But the concept of autoencoding was mind-boggling to me. Like, how does it work? But eventually it kind of sunk in and I got it. And it, by the way, completely blew everything we had tried out of the water. Like, it solved our problem overnight. A simple 10-line function in MATLAB solved that, back then MATLAB. And then that was the ground zero for our AI journey. At that point, we realized, hey, neural networks, they're back, and this is amazing, and the things you can do with it are just insane. CNNs came up, and then we followed everything up until graph neural networks, multimodal AI, and so on. So it was really medicine that was more fascinating for me, and then AI is just a means to an end to solve really challenging problems in healthcare. And there are challenging problems abundant in healthcare. So this was, but why did I like healthcare so much? Well, it was very rewarding to help doctors with this critical job. You know that ultimately your algorithms and models, they don't just help increase profit. Well, they do that too for the clinical administrators, but it ultimately the patients will benefit, hopefully will benefit. For students here in the audience, it's a fantastic career branch. It's a very future-oriented market. It's a multi-billion, I think multi-trillion-dollar industry. There are lots of jobs in this area, AI in medicine. There will be even more. Another interesting thing is that many parts of medicine are still in the progress of being digitalized. Yeah, digital pathology, for example, whole slide imaging. This is something that is done in a digital manner, but then there are no completely digitalized labs yet, very few worldwide. And even those lament that while they are working in a digital manner, the entire clinical branch of digital pathology, the day-to-day business is not fully digitalized. You cannot easily query a database for the 200,000 whole slide images of the last N years on this and that patient and so on. So a lot of things will still come. Multimodal AI is amazing. What you can do with language models and querying your data or embedding clinical text, free text, unstructured data, graph neural networks. There's so much that is happening. And if I think another aspect, like you were asking, how should students get into it? I would say push yourself. Don't take the easy way. Kind of work with doctors, really good doctors and really good technical leaders, work in good labs, technical labs. Try to collaborate with them externally if you don't have access to it. Try to get a remote internship or whatever, unpaid if it has to. I'm not a fan of unpaid work, but sometimes it just helps to progress and learn more. That could be a good payoff, let's say. Work on hard problems. Don't give up when it's done. Try to optimize it a little bit also. Performance optimization, something that I rarely did in academia, and it kind of bit me in the neck when I joined NVIDIA. I had a large learning curve there. Work on hard problems, be as hands-on as possible, implement stuff yourself. Dr. Faghani can testify it's the best way to actually learn what's going on, not just hear what's going on, but actually do it yourself. But don't reinvent the wheel. Use existing tech, just like Monai, as much as possible to demonstrate use cases and features and performance boosts that were just not conceivable before. Yeah, if you want to learn deep learning and start implementing your own CNN from scratch, well, you will only get that far, right? But if you use a toolkit like Monai, it doesn't have to be Monai, of course, but if you use something like that to use a state-of-the-art model, a 3D vision transformer, or a highly parameterizable unit, maybe even load pre-trained weights, it sounds like cheating, but it's not really. It's just allowing you to finally get to the next step. I did image segmentation and algorithms and AI for 10 years or so in my research, and I'm almost over it. Like, I think, okay, there are many good approaches and there can still be done more stuff, more research, but maybe it's also interesting to move beyond segmentation. Let's assume we have good segmentation models. Now let's see what are the hard problems after that. And yeah, and then the final thing in research, aim for A-level conferences, aim for A-level journals, because the reviewers will push you. And this is the thing that I said in the beginning: push yourself, don't go the easy route, solve hard problems. And in A-level conferences, the reviewers are sure to give you a reality check when you're too confident, and then you learn more. And that's basically it.
Yeah, well, can attest to that. The best thing you can do is submit to reviewer two's comments. It's the best way to learn.
Yeah.
Nobody else will give you reviewer two feedback except
Exactly.
reviewer two.
Exactly.
Yeah. All right. Well, one thing that I always make sure to ask anybody that we host on the Hub or at the Journal Club is where they see clinician engineers fitting in. So that is just sort of a term we came up with for med students who have put in time or have that background. So the same way, for instance, Dr. Faghani came from a mathematics background. There are medical students with us here today who have a computer science background but went into med school, or even vice versa, engineers who have worked a lot with doctors or who have sort of focused in on healthcare right from, undergraduate stage. Where do you see them fitting in the whole medical AI area in the future? And is it best for you to have, let's say a very good doctor working with a very good engineer, or is it best for you to have also people who have a little bit of both sort of in the middle? So question to the both of you. Yeah, Dr. Seyed's unmuted already, so I suppose really.
I don't mute myself anymore, so it's
all right, Dr. Shahriar, you can go. We could really just start with that.
Well, I guess the ideal answer is to have the great doctor and and a great people in the technician side. But I guess nowadays we need a lot of interdisciplinary people. So it's always good to have some skills from either side. But I guess still you want to be excelled in either of them, plus having the background from the other side, because the ideal word, the ideal scenario that I just described probably is not going to happen. You can't be the best in medicine and you can't be the best in in deep learning developments, for example, world, right? So, but I guess you can try to excel in one of them, and then it would be great if you can have at least some understanding from the other side. You don't need to be, I guess, programmer. You don't need to be a developer. You need to just have understanding of the other side. So a lot of medical students and a lot of residents always asking me, should I learn code? And my answer is definitely no. if you want to be in AI, no, definitely no, because it has a learning curve that it will take a time from you, and after 2 weeks you're going to be disappointed for 90% of the cases, and then you're going to even throw the AI at all. So no, I guess AI in clinical practice is inevitable. So you need to understand it. You need to understand the concepts. You need to understand the meanings of overfeeding, underfeeding, validation, test, train, and to me, most important part is the metrics. So you need to understand the metrics. If I want to sell you a model and I say, okay, this model is 90-70% accurate. So are you going to buy it? No, you should ask a lot of more questions from me. You need to understand, okay, accuracy is not always a good metric. So you need to understand what is the imbalance problem in the data set. You need to understand what is out of distribution. You need to understand how the data has been processed. You need to understand what is your data, what is the format. So these are the things, I guess, that people need to understand. But again, that would be great if people can do code, if people can develop something. Okay, excellent. But I think it's not necessary to be in AI ecosystem, AI in healthcare. So again, you need to understand the concepts. You don't need to do it. But the best way to learn it, of course, I agree with Dr. Ahmadi, is from learning, but that's not going to happen, I guess, for 95% of the cases. Yeah.
All right. Well, Dr. Ahmadi, have anything to add to that?
No, I really fully agree with that. It's I have to say some of the best, most impressive things I've seen came from doctors who can code really well. Those are really very rare specimens. That was one of the questions I asked to you, Dr. Faghani. Like, how did you get there? But it's the rarest thing, and it's understandably so because it's a dual effort. Not everybody can fit that. Not everybody has the prerequisites in tech as a medical student. And as a technician, I know that I will never be able to catch up with medical degree education. So you can have both typically. There is a tendency that, or this common thought that the most specialized people are the most valuable. That is true. And I can also say that as an intermediate person, when it gets too deep, I need engineers at NVIDIA. Luckily, we have them abundant here for MonEye, for even deeper stuff, GPU tech, CUDA questions, and so on. So you need these very deep specialized people, but there is a very, very valuable space in between that helps to communicate between the two worlds. And this is what you were saying, these, I think you call it clinical engineers. These people who are engineers, but understand the language of clinicians, who understand basic concepts in medical research, evidence-based research. And speaking of metrics and so on, you need to know the concepts, and you need to be able to explain it in a quick manner also. And you need to sort of have the big picture in view. And for the really hardcore specialized things, you can still rely on experts in both areas, but we can also get a lot of stuff done because we know both worlds to a sufficient degree. And I think that helps to bridge the gap between theory and application, and between hardcore tech and bringing it to the patient, sort of, let's say.
Wow, great. All right. So just to sort of wrap up and summarize what I heard from the both of you. So essentially, you do not need to have a programming background or a code background, computer science background, math, whatever it is, to get into the world of AI in medicine. It's more so learning the mindset and also how it is that you can evaluate a good model based on basic machine learning theory. So is that sort of what I got from your answers, but also best way of learning is also doing. And we've tried to do something very similar with our elective, where we try to sort of introduce, and even with our journal club, actually, we try to sort of introduce basic concepts and ways of evaluating models, because what we noticed was that there are a lot of really interesting papers out there on very, very good journals. But once you really read the fine print, and once you really get to, you know, like sensitivities, F1 scores and whatnot, it does not really match the title. You're not really getting what it's selling, essentially. So that was pretty much the aim behind the elective, more so than learning to create your own models. And so some of our students would come up to me later, because I was the one responsible for the hands-on sessions, and they'd be like, okay, I'm not learning how to create the code snippet itself. You're just teaching me to play, and then you're telling me what it does. Like, I expected to come in knowing how to build it. And I'd go, that's pretty much not the whole point. The point is to just know essentially how to review or how to spot good or bad models, but also to have the mindset or be able to relate to the developing team. Because like Dr. Seyed mentioned, sometimes doctors, want magic. And Dr. Faghani also talked about that. It's not really a magical model that can solve everything. It's more so of a process that you have to intervene in very frequently. But yes, I suppose we've come to the end of our webinar. This was a long one, but thank you to all the audience for sticking with us, and to the speakers. Hi, hello. Dr. Susu.
Yusra, hi, Dr. Shahriar and Dr. Ahmed, I guess. First, I want to apologize that I couldn't attend to everything you said, because I was in and out of boarding meetings every day, and I just finished. I want to thank you so much for the participation today, and I will certainly look forward to hear more about if there is a recording or more discussions. And special thanks to Yusra, of course, for organizing this. This is very fruitful and very inspiring to our medical students. I just wanted to thank you all. And apologize for not being listening all the time. Okay.
Of course, no problem. And thanks also to Yusra. Great organization also. Thanks a lot.
Thank you. Thank you. I really
Cool
appreciate
journal
it.
club that you're having.
Thank you. Well, we tried. All right. So I suppose this should be the end of the webinar. Oh, hi, Dr. Mitch. You made it. All right. So Dr. Mitch is very much so into the idea of NVIDIA Monar. And I tried to sort of answer some of the questions that you had back then at the Sidra AI conference. I'm hoping that I covered a few of them at least. Memory's not so good since May, but yeah. All right. I suppose this should be the end of it. Before we end though, I just want to make sure with Dr. Seyed and Dr. Shahriar, if it's okay that we upload this on the Clinician Engineers Hub YouTube channel.
Should be fine, yeah.
Good. Okay, perfect. All right, so that should be it. Have a great evening, everyone, and thank you so much for tuning in. Oh, you were here since 7:20. I know this, actually, I saw. All right, okay. All right, this should be it. Have a great evening, everyone. Thank you very much for attending, and hope to see you next month with our next webinar.
Great.
Thank you, Zena. Thank you, Dr.
Thanks for having
Rashid.
us.
No worries. Thank you so much. Oh, and I will connect you to Dr. Sumaya as well as Rehab. I believe Rehab had a question on mentorship. So if it's okay, I will connect you all via email.
Absolutely.
Right.
Thank you. Goodbye.
No worries. Bye.
Bye. Thank you, everyone.
Bye-bye.